Right, let's make a start, shall we? So, how many of you have finished with the OVS lab sheet? Hands up. Happy days. Good. Okay, so I will talk a little bit more about the last lab sheet that we have, which is called Populating the Cloud. I went online and I found a couple of links for you. So, some basic functionality for your cloud, some basic services. So, the first one I have is how to set up an NFS server. Okay, those links are all in the wiki. So these are just links, you can click on them and they will just take you there. Okay, so the first and easiest thing that you can do is you can turn your server into a file server. And the easiest way out of all of the many ways to do this is through NFS. Okay, network file sharing. Essentially, you need to download and install the NFS utils. You need to configure a file called exports that lives in etc. Tell it what to share and where. Then you need to create a folder or choose a folder that you want to share, and then run the service and all of its accompanying sub-services. Once you do that, you can go into your client and you can mount the directory, so you can connect remotely onto the directory and actually use all of the data from there. If you are going to do this, I would like this to be done automatically, so you need to look for something called auto mount. Okay, so that's the first and easiest thing that you can do. The second thing that you can do is you can install LDAP, configure it, and run it in your network. This is a bit more high tech than NFS because it doesn't just do file sharing, it does account and user management basically. So we use LDAP in the university so that you can log in with your UP blah 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 at MyPort UK everywhere in the university. So any computer that you use, whether it's Linux or Windows, that connects onto an LDAP server that also works with our Active Directory servers that provide user authentication and file management, home directory management, and all that. So if you do set up NFS and you're happy with it and you want to expand more, the best and most efficient way to configure all of your users for your cloud is to simply set up an LDAP server and configure your clients to be able to connect onto that LDAP server. Remember, you'll need to do this into one of the machines on the cloud, which will be the server. Before you try anything, take a backup of it. Okay, the easiest way to do that is to just duplicate the hard drive, essentially. Duplicate the image, give it a name, and do that. Okay, you can also try the snapshot feature if you want, which for persistent VMs actually works. All right, so you can set up LDAP, you can configure it. The point of this will be that by the end of it, you should be able to log into your lecturer or student virtual machines with an account that you have created on your LDAP server. So the user account should not exist locally in your clients. It should only exist locally on the server, and your client should know that when somebody is trying to log in, to go to the LDAP server and authenticate through there. All right. You can also manage those groups and sort out the grouping of who is allowed to use which virtual machine on OpenNebula. So there is a link on OpenNebula's website itself that goes into much more detail than what we did in LabSheet 3 about user groups and everything else. Remember, the groups that you have in your cloud at this stage are irrelevant to the user groups that will be able to run inside the virtual machines. Okay, so if you are a student and you're called John, you might have enough permissions to run a virtual machine in the cloud, one of the student virtual machines, that will not automatically give you the right to be able to log in to that virtual machine and use it. Okay, so your user management must be twofold essentially. In the end, if you want, and ideally you should, you can consolidate both of these. So you can set up contextualization on the server so that the users that you create in OpenNebula, they're the ones that work with LDAP as well. So you can get OpenNebula and LDAP to talk with each other and they can do this. This is really a cherry on top situation though, so leave this until the end. All right. Talking about contextualization in general, I would like you to try it so you can tell virtual machines in the cloud to do specific things. So you can give them instructions when they start. So the simplest example is the networking information. when you are starting a virtual machine up until now, then your cloud would say that this virtual machine should have an IP address of 148.197.30.65. But then once the virtual machine starts and you log in, you would notice that it doesn't actually have any IP address information inside it, and you have to go into the network card itself and configure it. You can check a box here and automate this process. All right, so you can get the virtual machine to get the contextualization information about the networking automatically from the system. So I want you to experiment with this and then use that for the lecturer and client virtual machines that you will create, because you will need it. Because if you are going to start running multiple instances of client machines, you don't want the user that logs into them to have to go and configure the network card every time. Ideally, they shouldn't have enough permissions to even do that. Okay, the virtual machine, once it's instantiated, once it runs, it should get the networking information that it needs to get from the cloud itself. And speaking of networking information and multiple instances, the easiest way to solve the problem with our lack of public IP addresses is to create new network cards in the cloud. So I have created here a network card that I've called net0, and I need to log in. So my net0 network card looks like this. Come on. Fine, let's do it the easier way. Okay, so my net0 network card is connected onto a bridge that's called VMnet0, which is a bridge that I have created myself, and it's located here. Yeah, and I've done this with the OVS VSCTL command. So in exactly the same way as you added VMnet 30, 31, 32, you can add whatever you like. You can add the network card and call it John. But please give it a meaningful name. Yeah. So my VMnet 0 is 192.168.0.1. All right. So if I go into my ifconfig, I now have a net 0 with an address of 192.168.0.1, because I have created the device through OVS VSCTL, and I have also gone into my network scripts folder and I've created the net0 network card that looks like this. All right, so exactly the same process as you followed for networks 30 and 31 will let you create as many network cards as you want. There's no limit. All right, now if I'm doing this, I would do it in as tidy way as possible. So I would create a net0 for my lecturers and a net1 for my students. So all students would be on 192.168.1 dot something, and all lecturers would be on 192.168.0 dot something. And in order to do this in OpenNebula, looking at the virtual networks, you can see that my net0 has 0 out of 252 leases. Yeah, an entire class C network, starting from 192.168.0.0, going all the way up to 192.168.0.255. Yeah, so we take out 2 for the network address, we take out 1 because we've given 192.168.0.1 already, and we've actually given 192.168.0.2. So these are the rest of the remaining IP addresses. So now as long as I make my lecturer virtual machines being able to instantiate, then they can automatically start using a net0 network card. And then if I make one virtual machine, it will have an address of 192.168.0.3. If I make a second virtual machine, it will have a 192.168.0.4. If I make another one, it will be 5, 6, all the way up to 254, sorry. Okay. So you can give the same network card to multiple instances of the same template. So you create your lecturer template, you allocate net0 to it, you're done. All right. You'll never get that little ping message on the bottom of the screen again that says could not allocate IP, marked leases are not enough, because this has an entire class C network, unless you decide to create 255 virtual machines. Okay. So and then I would allocate the network 1, 192.168.1.0 to the template of the students. All right. So any student virtual machine that starts up belongs to that network. Of course, you then need to make sure that your server is always starting up on the same IP address. I mean, really, your server should only have one IP address, and that your clients are all pointing to that same IP address for your server in order to connect and get services. Of course, you can also do something else that's cool. You can make hot backups of your server. Yes, once you've configured it, you can instantiate another one. You can clone it as many times as you like. So you can have some failover in the server itself. So if something goes wrong with your running server, you can have a backup server running at the same time. And when you configure a service running for your clients, you can give both the IP addresses, the primary server first, and then the backup server second. So even, and you can try this, you can pause, power off your server, and then your client should still be able to work. Yeah? And that's one of the biggest benefits of working in a cloud. You create a virtual machine, you create a server, you can get it running straight away. So you can have a hot backup, which is something that's on standby and it's running at the same time as your server. You can have a warm backup. You can have a virtual machine that's already instantiated but powered off, so it's not taking up resources. Or you can have a cold backup. You can have an instance of the template itself. You can have the image itself, and if you need it, you can instantiate it and run it so that it actually comes back straight away. So if your server crashes, you don't need to rebuild it. You just need to click on one button and the thing will just run again. Okay, so this is the whole idea and the biggest benefit of virtualization and having a cloud environment, essentially. All right, and the same pretty much goes with the students and lecturers. Even if your VM crashes or something goes horribly wrong with it, you can basically just start another VM or start a backup of the same VM running straight away. Okay, so if you want, these are all concepts that you can play around with and you can document them in your logbooks and they will give you marks, so you can do whatever you like with it. All right, I just want you to know how a cloud works and how the computers inside the cloud actually operate. Going back to the networking, that net 0 and net 1 network cards, or whatever else you want to call them really, they will need to be on a private network. You cannot just randomly assign public IP addresses. Okay, because they will be on a private network, routing will not work for them. Should not work for them. Yes, you can make routing work for them, but that would be wrong. So you could go on to ospfd.conf and say, oh yes, I want to advertise network 192.168.0.0. And then everybody else in the class will do the same, and then no one will have internet access. Hooray. All right. So because you cannot route to it, you have to NAT to it. The easiest way to do this, if I can find the file, yes I can, is to do something like this. So this command will basically NAT anything behind the network card that you are mentioning. Okay, so you have a network card which is ETH0. This will need to be the name of the network card that you're NATing behind. In your case, it will be ENS33. And because you're not using ENS33, you're using net28, it will be net28 really. And then you need to have the IP address of the source of the NATed network, as we call it. So that's going to be your 28.something IP address. If you include this statement every time you start your computer, or every time you start your networking, or if you include it in rc.local, or if you can put it in your IP tables rules in any other way, you can really do it whichever way you like, yeah? Then everything that's in your NATed network will get NATed through Prometheus and to the outside world. This means that you will be able to ping Google from your virtual machine clients that are on the private network. You will be able to browse the internet, do whatever you like, but those virtual machines will be hidden to everybody else around them. Okay, they will only be able to be contacted by machines that are on the same network as them. This also means that you're introducing some network segmentation into the network as well, because by default, none of the students' virtual machines will be able to contact any of the lecturers' virtual machines. and none of them will be able to be contacted by anybody else. Okay, so it's the easiest way to introduce a little bit of segmentation and security in the cloud itself. All right, you can also take this to a next step, and you can implement VLANs with OVS. Okay, you have to do your research, figure out how it's done, and do it. All right, and that will get lots of marks. But really, this is a very last thing, yes? So try to get your network, your virtual machines, your cloud to work in a simple way as possible. So make sure you have your 3 baseline virtual machines running correctly on the public addresses first, and then you can use any and all of these and do whatever you like, as long as in the end we have your clients and they're able to connect to your server and log in, get a username and password and a home directory. Okay, so this is my requirement for this lab sheet essentially. All right. So yes, the most basic concepts are these ones. Do you have any questions that you would like to ask me about all this? So you can do whatever you like. So leaving it on subnet 28 to begin with would be the easiest way and most straightforward. However, if you do decide to make a backup for it, you cannot have another IP address on 28. You can put it on 30 and have 2 addresses, so you can have your normal and backup. Or if you want to, you can put everything on private addresses. So put the entire cloud in private addresses and set it up like that. Yes?
Do we need to add the settings in the program or new network?
Sorry, what?
So that new private network, do we need to add them to the program on the other device?
As I explained, no, because you need to NAT to them, not route to them.
IP forwarding is actually enough to routing this.
You shouldn't You shouldn't route to private networks. Yeah? Because if you all have the same network address, then you'll cause confusion and routing loops and everything else that we really don't want. Okay, so don't make any changes to Zebra and OSPF. They should only have 30, 31, 32. All right, and 28, of course. Anything else with private networks, all you need to do is type this nothing command, and that's it. All right. Anything else? All right then. Thank you very much.